Good afternoon everybody, welcome to this session of structural engineering design and detailing. As I had explained you all in the previous class the importance of structural steel and the structural members, and I had given you all examples of many buildings and many skyscrapers that have come up in America, and the biggest advantages of these steel structures are it takes very less time compared to reinforced concrete structures. As I had given you example of a Chrysler building which is of 73 floors, it took only 2 years to construct this building, whereas if you take reinforced concrete structure, it takes a lot of time compared to these structures. But still there are some disadvantages. That is why in India still we don't opt for structural steel members for high-rise buildings. So the biggest disadvantage I had told you, the problem is the steel gets corroded very easily. So a lot of maintenance is needed. If that is not done properly, then the consequences might be very high. And the next disadvantage is the steel members, when come into contact with fire, they can't resist this fire for a long time, and because of this there are there are high chances of collapse. And in the previous case studies that have been done for skyscrapers, many buildings which have collapsed, one of the biggest reason with steel structures was it collapsed due to the effect of fire. So anyway, but still steel structures are very important. One important aspect where we use steel structure is the plate girder. Today we will be dealing with today we will be seeing what is the importance of plate girder, its components, typical components, and its design. So where is plate girder is needed and what is the importance of plate girder, that I will be showing you all today. Let us see that what is a plate girder. A plate girder is a built up I-beam section used to carry heavy load. So basically this is the I section. If you see the cross section of this beam, it is a I section. It has top flange and the bottom flange as well as web in the between. So these all these are made of steel structure. They can be either bolted or riveted, or they can be welded also. It is made up by bolting or welding the steel plates in I-beam shape, as I had told you all. So they are used to connect two bridges, providing free access without any obstruction. So basically plate girder is that structure which connects two bridges so that there is no obstruction in between. At some places where the bridges have come up, but still if you want to avoid some obstruction at those places, you go for a plate girder. If you can see the figures, inshallah you will get very much you will get a very good clarity of what is plate girder. My basic concern of making this PowerPoint presentation is I could have explained you all this on the board, but still I felt if I explain you all on board, you all wouldn't have got clarity. Everybody can't imagine what I am telling. Everybody has a different perception of seeing things. So I thought it is very important that I should come up with PowerPoint presentations. Once this is clear, once this concept is clear and you all know what is plate girder, then inshallah in the next session we will be coming up with the design steps, and then in the later stages we will be doing up a problem. So let us see. The plate girders are generally provided for large spans greater than 18 to 20 meters. As you can see here, if the spans are very high, they are between 18 to 20 meters, and we want to avoid an obstruction. At those places we come up with plate girders, and generally these plate girders are fixed at those places where we want to connect bridges, where we want to run a railway line over these bridges, and at the bottom we want to avoid obstruction. And even at the places where there is a stream is passing by, we want to connect a bridge, and we can't come up with a structure in between the stream. At those places also we use this plate girder. As you can see here, plate girder has enormous flexural strength. Even the flexural strength is very high in the plate girder. As you know, when the load acts onto a beam, the load acts as a UDL, universally distributed load, and it acts as a UDL load. Because of that, there is high bending moment at the center. So basically to resist this bending moment, plate girder we fix a I section, and this plate girder resists this bending moment, and therefore it gives you very high flexural strength. The resistance to bending and shear can be increased by increasing the distance between the flanges. As I had told you, you have a top flange and a bottom flange. If these distances are increased, the resistance to bending and shear can be increased. Because of the external load coming onto this I section, there are high chances of shear also, and basically this shear is resisted by the web. web resists the shear. So if we increase the bottom and the top flange, this resistance can be improved. Next, you can see the plate girder bridges are suitable for short to medium spans and may support railroads, highways or other traffic. As I had told you, where we want a continuous traffic of highways, and there is no possibility of coming up with a reinforced concrete structure in middle of the highway. At those places we can connect this plate girder. And you must have seen in the city also, where metro rail have come up. At some junctions you can see a steel structure connecting this metro bridges rather, you can say. So at those places this have come up. Basically this was to avoid column coming in between in middle of the junction. So this plate girder plays a very important role in connecting two bridges. You can just see the typical components of plate girder. You can see there is a top flange and a bottom flange. You have web and vertical stiffness and horizontal stiffness. In the further slides, I will tell you what is the importance of vertical stiffness and horizontal stiffness. Even they play a very important role in giving strength to these plate girders. Now you can see a figure here. At the left and the right you can see the figures here. This is a I section. How does the I section? Basically this I section is because of the cross section that is formed. You can see the top flange, a plate is fixed there, and in the between you have a web, and at the bottom also you have a flange. So that is the top and the bottom flange. And these members, or you can see the steel members coming out, these are the vertical stiffeners that are being provided. In the figure at the right side also you can see you have transverse stiffness and longitudinal stiffness. Longitudinal stiffness are basically horizontal stiffness, and the transverse stiffness are also vertical stiffness, which give resistance against loading. Let us further see. Just as I had told you, plate girder connects two bridges. You can see here a rail is running over these bridges. We want to avoid any obstruction below this bridge. So that is why we have come up with a plate girder. In the right figure also you can see a plate girder has been fixed in a mountainous area. As you can see there, though two columns are there, concrete columns, reinforced concrete columns are placed there, but in between these two columns there is no possibility of placing another column. So at this point we have placed a plate girder. As you can see, above this plate girder you have a railway line passing over it and giving it free access. So this is a very important structure. Plate girder is a very important structure, but it should be designed accordingly. If it is not designed accordingly, then there are high chances of collapse. And the other thing about structural steel members, as I had told you, the biggest problem or the disadvantages, as you can say, is it needs lot of maintenance. Basically it needs maintenance against corrosion. If the structural members are not given maintenance against corrosion, then there are high possibilities of it yielding and thereby leading to collapse. You can see this figure as well here. This plate girder is connecting these two bridges. You can see here a railway line is passing over it, and it is riveted here. This is a riveted plate girder. Rivets have been used here. You can see here, basically this is a box type plate girder. It's a box type plate girder. Two plate girders are fixed with braces at the bottom, and over it a railway line runs over it. You can see in the next figures also, you can see it here as I had told you all. See, you can see two plate girders. They are fixed together at the bottom with the braces, and above it you can see the railway line passing over it. So this is a box type plate girder. You can see there is lateral bending also. To resist lateral bending, flanges give strength to this lateral bending. Against top cover plate is also placed there, you can see, and intermediate stiffeners are also there. Basically even they are placed to provide to resist lateral buckling. You can see in the next figure also there, web plate is to resist shear. As I had told you all, because there is high possibility of shear happening here because of the external load, as there is a high amount of load coming over these plate girders, there are high chances of shear. So to resist this shear, a web plate is provided. You can see a flange resist bending moment developed due to heavy loads. So flange is resisting bending moment. So a thick I section is being provided, top flange and the bottom flange is there. Over it, these railway lines are being placed. You can see here top flange resists compression. So basically the importance of top flange, it resists compression, and the bottom flange resists tension. So this is the importance of the top flange and the bottom flange. You can see here these plate girders have been placed over these bridges, and you can see though they are concrete bridges at the bottom, and these plate girders are provided. You can see there are 5 plate girders, and then these plate girders are connected internally. Now over this a railway line runs, or a highway can be, highway runs over it. So you can see here basically we have provided this to avoid obstruction at the bottom. You can see here now the importance of stiffness. Why are stiffness provided? So you can see the figures here. Longitudinal compression stresses in an unstiffened web due to bending. Basically to avoid bending, we provide these stiffness, so they resist this longitudinal compression stresses. So these horizontal stiffeners are provided, you can see here, to resist compression stresses. And you can see the next figure as well. Top flange of beam could cause local buckling along the length of the web. So there are chances, because as you know what is the buckling. Buckling is basically when heavy load comes from the top, there are chances of web bending away. To resist this bending, we provide vertical stiffness so that this web shouldn't buckle down. So stiffeners are provided to safeguard web against local buckling. Next, you can see horizontal and vertical stiffeners are generally required when the depth of plate girder is greater than 2 meters. Now this is important here. When do we provide this horizontal and vertical stiffeners? You can see here the web sometimes because of the external loads, when they are very high. As you can see, when the deck slab is designed, there is a huge, there is very high amount of load coming over it. As there are different class of vehicles, we have a tracked vehicle and a wheeled vehicle. Class A tracked vehicle, it has about 700 kilonewton of load. So it is a very high amount of load. Under those situations, when we want to go for a plate girder, we have to, as the load is very high, the web of the plate girder will also be more than 2 meters. In this situation, as the web is increasing, we will have to go for horizontal and vertical stiffeners to give resistance to bending and shear. As you can see here, you can see the importance of vertical and the horizontal stiffeners. Now this buckling could be prevented by adding longitudinal web stiffeners. You can see the figure itself shows here, but transverse web stiffeners will also be effective. So transverse means vertical stiffeners are of 2 types. You can see intermediate stiffener and end bearing stiffeners. So in transverse stiffeners, again we have 2 types of stiffeners, that is intermediate and end bearing stiffeners. Now I'll just show you the figure, what is the intermediate and end bearing stiffeners. Let us go to this previous figure. You can see here the vertical stiffener which is provided at the ends, that is called as end bearing stiffener. See, as there are chances, because of loads there are chances of web buckling away, the same situation can happen with the flange also buckling in a horizontal direction. So, to overcome this, we provide an end bearing stiffener which is placed at the corner, and other than that, whichever stiffeners which are not placed at the corner are the vertical stiffeners, or you can rather say they are intermediate stiffeners. So this is the importance of intermediate stiffeners and horizontal stiffeners. So it is very important we have to place these stiffeners, or else there are very high chances of failures. Now you can see the modes of failure here. Yielding of tension flange. As I had told you, the tension flange resists bending. Because of the high load, their tension is formed at the bottom of the flange, and because of that there are chances of yielding away, yielding cracking, and thereby leading to collapse. And you can see here the next mode of failure is the buckling of compression flange. As there is load from top also, first flange, that is the top flange, undergoes compression, and because of that there is chances of buckling. So even this is, if we know the types of failure, we can go for some methods where we can overcome these failures. So that is why vertical and horizontal stiffeners are provided. Next, you can see flange local buckling. Flange also buckles down. Complete flange from top to bottom, it buckles down also. So we have to overcome this also. Next you can see lateral torsional buckling. As torsion, you know, torsion basically you can understand with this example. You just take a cloth, and when you are drying it, you catch it in both of your hands and you twist it. This is torsion. So there are chances of the web as well as the flange buckling away in a torsional form also. So we have to go for some we have to adopt some measure where we can resist this buckling also. Next, you have diagonal compression of web buckling also. As you can see, because there is high amount of load coming from the top, and the web and the flanges are fixed together, they are welded or bolted or riveted, so there are chances of diagonal compression also. They can compress in a diagonal way also. From 4 sides it can get compressed, so that this is diagonal compression. So all these types of failures are there. If we know these are the failures, then we can adopt measures to overcome these failures. So basically this was the importance of plate girder. Hope you have understood what is plate girder. If these plate girders are placed properly, it plays a very big role in connecting 2 bridges and avoiding giving a free passage, avoiding any obstruction coming in between. So plate girder plays a very important role in connecting 2 bridges, and it takes very less time. As I had told you, structural steel members don't take such time where compared to reinforced concrete structure. In America, I had given you many examples of the huge skyscrapers that have come up in America. They have taken very less time compared to reinforced concrete structure. That is why plate girders play a very important role in connecting bridges or highways. Hope you all have understood this session. Basic need of this session was I wanted you all to get a good clarity of plate girder. Once you are aware of what exactly is plate girder, then we can design it. We have to design the top flange and the bottom flange as the web as well. We need to know the depth and the thickness of flanges. We need to know the length of the web and thickness of web also. Then later on, as per the need, we will be designing the vertical and the horizontal stiffness as well, end bearing stiffness also, and horizontal stiffness also we will be designing. So hope this session will be very informative to you. I request all of you all to please go to this session and please comment in the comment box. Your questions will make me more informative. I hope you all have enjoyed this session. Thank you. Thanks a lot for listening to this lecture. Please give your attendance in the comment box. Thanks a lot for your patience listening.